Good morning, students. Welcome back to science class in the chapter electricity. Today also we'll discuss some problems. Okay, first one. Find the equivalent resistance between point A and B in the given circuit. B in the given circuit. Yes. So here find the equivalent resistance between a point A and B in the given circuit. Find out. So here for resistance, so for resistors, find the equivalent resistance or total resistance in the circuit. Quick. Before solving, just think whether the resistors are in series or parallel. Okay, series means what? So end-to-end connection. There is no one more. Okay, for example, see here. If you connect like this, we can say that these two resistors are in series. If you connect one more here, then we won't call these resistors are in series. But if you connect here, then we can say that the three resistors are in series. Okay. Just observe here, this resistor, total three resistors are connected to one point. So we can say that these three resistors are in parallel. Okay. Yes. And this combination with respect to this, both are in series. Do it. So find the equivalent resistance between A and B in the given circuit. So first take RP. So R is equals to 6.5 ohm. No, it's wrong. Tanuja Guptedar. Your answer is wrong. Yes, we know the formula in the ratios and parallel. So I will take 1 by Rp is equals to 1 by R2 plus 1 by R3 plus 1 by R4. Okay, so choose the values and tell me the answer. So R2 is 10 ohm plus R3 is 5 ohm plus R4 is 1 ohm. Okay, yes. Yes, first total resistance is 10 ohm. Okay, first find out the Rp. Total resistance is that is 10.7. So 1 by Rp LCM is 10, right? Here 2 and here 10. That is 2 plus 10. Correct? Okay. Next, so 1 by Rp is equals to 13 divided by 10. We need Rp, right? So Rp is equals to 10 by 13. So what is the answer? 10 by 13. That is 10 by 13. 0.76. That is resistance. 0.76. Yes. 0.77. 0.77 ohm. Okay. Yes. So now we can redraw. We can redraw this circuit as like this. Okay. So now RP is 0.7 ohm. Okay. So now these two resistors are in this. So calculate the equivalent resistance. To calculate equivalent resistance, we know the formula, that is R is equals to R1 plus RP, that is R is equals to R1 is 10 plus 0.77. So totally R is equals to 10.77 ohm. Okay. So finally we get the total resistance from the system or from the circuit, that is equal to 10.77. Next one. What is the reading? What is the reading of ammeter? Reading of ammeter. What is the reading of ammeter in the given circuit? In the given circuit. In the given circuit, when first question A, the key K, okay, the key K is off, and B, the key K is on. Okay, is on. Draw this diagram. Forum. Two. Yes. So now fine. First case, so now here key is off. Okay, the second case just mentioned key is on. So find the current. So tricky one. So think and do it. I'll give 2 minutes time. Answered Neeraj Gupta, Shreyas DR, Neeraj Gupta and Raghavendra Adiver, Varun Bhiman Gowda. I is equals to 0 when the key is off, it's wrong. Okay. See here, when the key is off, okay, electrons through this resistor, but these two are connected. These two are connected. When the key is off, still these two resistors are connected. There is no current through this resistor. When the key is off, when the key is on, then the current flows through this resistor also. So now here key is off. So that's why there is no movement of electrons or there is no current through this resistor. So when the key is off, don't consider this part. Just consider this one and this one. Okay? Yes. Calculate the current. Says near I equal to 2 ampere when the key is off. No, it's wrong. See here, when the key is off, then there is no movement of electron. So which means these two will become series. Okay, yes, here you have joined one extra wire, but there is no movement of current, right? Okay, so now you can redraw this circuit as like this. When the key is off, you can draw circuit like this. Okay, see here I have connected one wire here, correct? But here there is no connection, right? Here there is no connection, which means still these two are in series. Okay, see here. See here. Here now clearly we can say that these two are in series. If you add one more like this, still these two are in series. Why? Because see, this side is connected but this side is not connected, right? So that's why that, see, when the current flows through the circuit, when the circuit is closed, but here see here, this circuit is closed but this resistor is not closed. Why? Because here there is no connection. Suppose if you join this one here, okay, then we can say that these three are in parallel. Okay, but if you draw like this, just see here, now we can say that still these two are in series. But if you connect like this, there is no movement of current, there is no movement of current through this resistor. Why? Because this side, this resistor is not connected. Okay, so that's why there is no movement of electron through this resistor. But if you connect here or somewhere, then current flows through this resistor. Then we can say that the resistors are in parallel. But still, there is no connection right this side. So still we can say that these two are in series. So here also same. Here this is connected, but this side there no connection, right? Here the circuit is broken here. Okay, so that's why we can say that still these two are in series. Okay, now we need current. Correct? Yes, we know the voltage, that is 9 volt. First calculate the total resistance of the circuit. So that is R is equals to, I'll take as RS is equals to so take R1, R2, and this is R3. Okay, so here current is 1.5 when the key of no is wrong. I think. Yes, no, it is correct. Okay. So here RS is equals to R2 plus R, that is 4 ohm plus 2 ohm. So RS is equals to 6 ohm. Clear? So now you can redraw. See, total resistance from these two, that is RS is equals to 6 ohm. Correct? Now calculate current. So V is equals to I into R. Here R means what? RS here. Okay? So still here there is no movement of current through this resistor because still the circuit is off. Okay? Next. No, you can redraw this circuit as here. You can redraw this circuit like this. RS. Take R only, don't take RS. You get confused, okay? So now R is equals to 6 ohm. Okay? So you can redraw. R is equals to 6 ohm. Now calculate current. Yes, V by R equal to I. That is I equal to V by R. Substitute the values. That is 9 divided by 3. So you will get 6, right? 6. So you will get 1.5 ampere current. So now here when the key is off, okay. Next, when the key is on, at that time you can't use this one. At that time you can't say these two, this one and this one resistors. Okay. So now redraw that same circuit. So here, so R2 is equals to, that is 4 ohm. R2 is equals to 4 ohm and this is 2 ohm. Okay. Key is on. Now key is on. Key is on. So now this resistor is connected to this circuit. Yes. So now we can say that the resistors are in parallel. We can't say the resistors are in series. Why? Because this end is connected, right? Yes. First calculate the equivalent resistance. Yes. First solve these two. If you solve these two, it will become 1. Then it is this combination is series with this one. First solve these two, R1 and R2. Here now these two are in parallel, but this combination is in series with this one. Okay, first I write RP. 1 by RP is equals to 1 by RP is equals to 1 by R1 plus 1 by R2. That is 1 by 8 plus 1 by 4. Okay, 1 by RP is equals to. So LCM is 8 only, here 1 and here 2. It is 1 plus 2. So we can write RP is equals to 8 divided by 3. So what is the answer? 8 divided by 3? 2.67 ampere. Okay. 2.67 ohm. Okay, not ampere. 2.67 ohm. Or it can keep 8 by 3 ohm only. Even that is also correct. No need to write 2.67 ohm. We can keep 8 by 3 ohm also. Yes. So now we can redraw. Now we can redraw this circuit as like this. So now it is a series with this resistor. So here RP value is here RP is equals to, I will write 8 by 3. 8 by 3, or you can write 2.67 ohm also. Both are correct. Okay. Yes, here many students answered. Neeraj Gupta, current is 1.5 ampere, first one, 1.5, 1.5, 1.5. So 1.95 when key is on. Is it correct or wrong? Yes, correct. When key is on, the current flows through the ammeter, that is 1.9. So now first solve these two resistors. Now these two are in series. Okay. So R is equals to RP plus R3. That is 8 plus 3, 8 by 3 plus 2. So LCM is 3 only. So here take as LCM is 3, and here you have to into 3, that is 8 plus 6. Okay. So 8 plus 6, 14. It here R is equals to 14 divided by 3. So what is the answer? 4.7. 4.67 ohm. Okay. So now once again we can redraw this circuit as so RT is equals to R is equals to 4.67 ohm. Yes. Now calculate current. Yes. Next one. So calculate the equivalent resistance. Ohm, 8. Yes. So find the equivalent resistance. Okay. Yes, correct. Here some students answered. Abhishek 003, that is I equal to 1.92. Okay, Raghunandu 1.9, and they are correct. Now leave that one. Now do this one. Find the equivalent resistance between point A and B. Just think and do it. First see where the two resistors are in series and where the two resistors are in parallel. Okay, just try to redraw the circuit. How we can redraw this completed circuit? Okay, you know, just imagine this is a straight line. Okay, so now we can do this line like this. Okay, here the problem is also same. It's fast. I'm waiting for your answer. R1, R2, R3, and this is R4. Okay, now just observe here, there is no connection here, right? So clearly we can say that these two are in series. Okay, and here also there is no connection, but these we can say that these two are in series. Okay, yes, do it. See here, you can redraw this circuit as like this. A and B. See, very simple. Okay, now you can redraw this circuit like this, A and B. Like this as R1 and this R3, and this is R2 and R4. 4 ohm, 8 ohm, okay, and this is 4 ohm, 8 ohm. Now you can redraw this circuit like this. Simple one. Okay. Now first RS1, that is R1 plus R4. R1 plus R3, that is 4 plus 8. 12 ohm. Correct? Okay. Now you can redraw this circuit like this. So RS1 is equals to 12 ohm. Next, RS2, R4 and R2 and R4. R4 same, right? R2 is 4 plus 8 is equals to 12. This is RS2. Here also you can redraw this circuit like this. RS2 is equals to 12. Okay. Now these two are in parallel. So use parallel formula. This 1 by R is equals to 1 by RS1, 1 by RS2. That is 1 by 12 plus 1 by 12. LCM is 12 only, right? So 1 plus 1. So we can write R is equals to 12 divided by 2. 2 ones are, that is 6 ohm. Correct? Yes? Yes, sir. 1 plus 1. That is 2.
12 plus 24.
Okay. Yes, so here the resistance is equal to 6 ohm. Next one. Yes. Here also find the equivalent resistance. Equivalent resistance between A and B. Do it. Find the equivalent resistance between A and B. Calculate the resistance between A and B. A and B. See here these two are in series, but these two are not series because this is the end point. Okay. See here. This is point A and point B, or we can say that this is point B like this. Okay, here the given, right, this is a point B point, but here this is not a point. Okay, so that's why this is a point. Now see here, now we can't say these two are in series because this is a point, means here one connection is there. Okay, so that's why, see, sometimes they will give like this. Sometimes they will give like this, calculate the equivalent resistance, or sometimes just they will give like this, A and B. Clear? So which means these two are in parallel, right? Here also, here they have given point, so that's why these two are in parallel. Okay. Yes, first to solve these two. First solve, wait, I give the names. R1, R2 is equals to 2 ohm, and this is R3, R4, R5. Okay. Now first in RS1. Okay. RS1 is equals to R1 plus R2. That is 2 plus 2 is equals to 4 ohm. Okay. 2 plus 2 is equals to 4 ohm. So now you can redraw this circuit like this. Like this. So now this is RS1 is equals to 4 ohm. Okay. Yes. Next. Just think where the resistors are in series and where the resistors are in parallel. See here. Now these two are in parallel. Okay. So now solve these two. So RP1, I'll take 1 by RP1 is equals to RS2. 1 by RS1 plus 1 by R4. That is 1 by 4 plus 1 by 4. So 1 by RP1. So 1 by RP1 is equals to LCM is 4. That is 1 plus 1. So RP1 is equals to 4 by 2. That is 2. Okay. So now you can redraw this circuit into like this. Now it is RP1. RP1 is equals to 2 ohm. Okay. Next, what is the next step? Total resistance. So no. Now just observe here and here. Okay. Yes. What is the answer? 2 ohm. Yes. Finally, you will get the total resistance that as 2 ohm. So equal resistance from this circuit, that is 2 ohm. Srija Guttelar 8 ohm wrong. See here, this is the point A. Okay, you can't take all are in series. This is the point A, but just observe here, this is not a point. These two are point. They have told calculate the resistance between A and B. A and B. Okay, so that's why these two are points. Now just observe here, this one and this one, both there is no connection, right? So we can say that these two are in series. Now I take RS2 is equals to RP1 plus R3. That is 2 plus 2 is equals to 4 ohm. Okay, 2 plus 2 is equals to 4 ohm. Now we can redraw this circuit, entire circuit like this. A and this is B. Now RS2, right? That is 4 ohm and R5 is equals to 4 ohm. Now both are in parallel. So finally you will get 2 ohm. Okay. So now you can redraw this circuit like this. Yes, Abhishek 003 R equal to 2 ohm, correct. Anushayam R is equals to 2 ohm, correct. So finally we can calculate R is equals to 1 by RS2 plus, sorry, 1 by R, right? Parallel. Then 1 by R5, that is 1 by 4 plus 1 by 4. So 1 by R is equals to LCM is 4, that is 1 plus 1. So finally R is equals to 1 plus 1, that is 4 divided by 2. Take the reciprocal. Okay, R by 2. So 1 is 2, that is R is equals to 2. So once again, finally we can redraw this circuit like this. A, D, and this is O. Okay. See, now I will give you homework for you. So find the solutions for this question. Two, 1 ohm, 2 ohm, 1 ohm, 1 ohm, 1 ohm. Okay. So here find the equivalent resistance between A and B. First one and second one. One ohm. Okay. So here we find the equivalent resistance. Yes. This is our homework for you. Okay. We'll continue in the next class. Thank you.